Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be simplifying a really cool expression with complex numbers. Wait a minute, what does this have to do with complex numbers? You might be asking, right? E to the power something something. Well, we'll talk about Euler's formula, the most beautiful equation, so on and so forth. So, when you get an equation like this, or an expression like this rather, how do you simplify it? That's the question, right? How do you simplify something like this? Well, first of all, I noticed that this expression is the square root of this expression. Have you noticed that too? If you did, comment down below. But if you call this z, this becomes z squared. And you might be asking, why? Well, if you go ahead and take this expression and raise it to the second power, what's going to happen with the exponents? They're going to be multiplied, right? When you multiply them, the 2 is going to cancel out, giving us e to the power I theta, which is what you have, or part of what you have, in the denominator. So what does that mean? It means what I just said. This is z, that is z squared. So doesn't this expression turn into something like z divided by z squared plus 1 then? Yes. Can we simplify this? Well, if you don't know what z is, you probably can't, but maybe we can assume the following. Suppose z is equal to a plus bi, and why is that significant? Because it's the name of this channel. That's why it's super important. Don't forget that, okay? You can write a complex number. What is a complex number though, right? I is the square root of -1, or you can express it as I squared equals -1. By the way, if you're new to complex numbers, go ahead and check out my lecture videos. I have another channel, Cyber Math, Cyber with an S. If you like algebra, number theory, and trigonometry, tiny bit of geometry, you'll find it there. Make sure to visit. And let me know what you think, all right? So, how do we solve this problem with z equals a plus bi? Or can we solve it? Who knows? We got this expression, and that's what we're supposed to simplify, right? So we start with that. I'm going to go ahead and replace z with a plus bi. How do you find z squared, right? Well, you just have to take a plus bi and square it like normal, paying attention to the fact that I squared is equal to -1. That's the only thing you need to pay attention to. And when you factor this, you're going to get expand it, a squared, and then b squared, I squared, but I squared is -1, so it's going to be minus b squared. And then 2ab thing, 2abi. All right? So that's our denominator. And when you are dividing a complex number by another complex number, how do you simplify that? Use the complex conjugate, right? Again, if you don't know what that means, I'll tell you real quick. The complex conjugate of a plus bi is a minus bi. All right? So we can define a function actually that turns this into that, but that's a different story. Now, here's what we need to pay attention to is that the real part of the complex number in the denominator is a squared minus b squared, and this is the imaginary part. So its complex conjugate is going to look like this. A squared minus b squared is going to stay the same. You're just going to negate, that's the word, that you're going to negate the imaginary part. Does that make sense? I hope it does. Now, what's next? We're going to multiply by the same thing in the numerator, and things are going to get very messy from here. You ready? Okay, let's see what that looks like. Now, we're going to go ahead and distribute, and make sure to multiply real by real first, and then you'll get the real parts, and imaginary by imaginary, again, part of the real parts, so on and so forth. Anyway, you distribute, it's going to look like this. And then bi and that, it's going to give us a plus sign because of I squared, 2ab squared. That's the real part. And I'm going to distribute this over that. It's going to give me minus sign. This is going to give me a plus sign. So let me start with that. B times a squared minus b squared. And then I have to minus 2a squared b. And this will be the coefficient of I, which is the imaginary part, okay, of the product, or whatever that is. So now, in the denominator, when you multiply x plus yi by x minus yi, you need to know these things. You get sum of two squares from difference of two squares, whatever that means. So here in the denominator, you should be getting a squared minus b squared squared plus 4a squared b squared. Can this simplify at all? Who knows? Let's give it a try. We're going to go ahead and distribute here. We're going to get a cubed minus ab squared. Actually, we could probably factor out an a here, I'm thinking, and a b maybe. That might be helpful. Let's do that, okay? Because this is going to be like back and forth. So why don't we just take out an a. That gives us a squared minus b squared plus 2b squared. Okay, 2b or not 2b. That's good. And here we can factor out a b. That's a squared minus b squared minus 2a squared. Awesome. I think this worked. Great. And then the whole thing is divided. Now, what happens here? If you know x minus y squared plus 4xy, if you know that identity, this is x plus y squared. Take a look at it and think about what that would work, but you can also expand it and prove it that way. But I'm just going to take a shortcut here. So in other words, in the denominator, we have a squared plus b squared squared. Make sense? It does. Now, we can simplify here, these two and those two. So a times a squared minus b squared, and here b times negative a squared minus b squared. Okay, divided by a squared plus b squared squared. Cool. Now, how do you simplify this further, right? Well, we can probably factor out a minus sign here. That would look like a times a squared. Wait a minute, I messed up. Sorry about that. This is supposed to be a plus sign. Yay, negative b squared plus 2b squared. I always make mistakes. But I fix them quickly, right? Don't I? Here, if you pull out a minus sign, you'll get an a squared plus b squared inside the parentheses, right? And then this should work nicely, right? Hopefully. I don't know. We'll see. We can factor out an a squared plus b squared now. Beautiful. Now that'll be multiplied by a minus bi. And then in the denominator, we have a squared plus b squared squared. Now these two are going to cancel out. And we're going to end up with a minus bi divided by a squared plus b squared. Wait a minute. Where does a and b come from? We didn't have those, right? We had the theta. So we kind of have to go from this world to the theta world. But how do we do that? And thanks to Euler, we can do it. For example, if you have a complex number a plus bi, which we assume to be z in this case, remember? And what did we call z? Z was e to the power I theta over 2. So you got to be very careful about that. E to the power I theta over 2. Not the denominator, but the numerator. Because when we squared it, we get the e to the I theta. Remember that? Okay. Now, what does this mean? Here comes the Euler formula. Euler's formula. Here comes Euler. We can write this as cosine theta over 2 plus I sine theta over 2. Okay, but how is that helpful, right? Well, here's the thing. If z is a plus bi, isn't this z bar? In other words, the conjugate of z, yes. And isn't this the absolute value of z? That is interesting, sort of, right? What is that supposed to mean? Well, if you started off with the theta, maybe we can write it in a different way. If z, a plus bi is equal to this, then a minus bi is just going to be the complex conjugate. So this one, right? This is z bar. And what about the absolute value? The absolute value is 1. Why? Because cosine squared plus sine squared, I can show you. Cosine squared theta over 2 plus sine squared theta over 2. This is the modulus, which is equal to 1. So we only need to worry about this. And guess what? That is the answer in terms of theta. Cosine theta over 2 minus I times sine theta over 2. What was the original problem, right? The original problem was e to the I theta over 2, e to the I theta over 2 divided by e to the I theta plus 1. And it's equal to that. Is that good enough? Or should we turn it into exponential? Yes, you can do that. Thanks to Euler again, because e to the I theta can be written as cosine theta plus I sine theta. This is the most beautiful equation, by the way. You could replace theta with anything you want. This would turn into e to the power negative I times theta over 2. But can someone explain why this is happening? Why this is working? Wow, this is complicated, isn't it? That's why there is a second method, which is usually more elegant, shorter, and usually better. But again, it's up to you to decide, okay? So I'm going to start with this, and why not use the Euler's formula right away, right? So turn this into cosine theta over 2 plus I times sine theta over 2. And then divide it by cosine theta plus I sine theta, which is e to the I theta by Euler's formula plus 1. Now, here's the million-dollar question. How do you take care of plus 1 here? How do you handle that, right? And here comes the beautiful trigonometry. Ta-da-da-da. We're going to use double angles. But it's kind of like a half angle because we're looking at half of theta. In other words, cosine theta can be written as 2 cosine squared theta over 2 minus 1. And sine theta can be written as 2 sine theta over 2 times cosine theta over 2. Again, these are double angle formulas. And when you do that, something miraculous happens. Let me show you. This is really, really cool. I'm going to keep the numerator. In the denominator, I have 2 cosine squared theta over 2 minus 1 plus I times 2 sine theta over 2 cosine theta over 2 plus 1. The minus 1 and the plus 1 are going to cancel out. And now we have a common factor, cosine theta over 2. So we're going to write this again, cosine theta over 2 plus I sine theta over 2 divided by, we're going to factor out 2 cosine theta over 2. And inside we're going to get cosine theta over 2 plus I sine theta over 2. And then guess what? Cosine theta over 2 plus I sine theta over 2 is going to cancel out. And we're going to end up with something like this. But the $1,000,000 question is, why does this look like that? That's for you to find out. Because this brings us to the end of this video. Thank you for watching. If you enjoyed it, please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care. Don't forget to check out Cyber Math and A+BI, and bye-bye.